All right, so for today's lesson, we're going to be talking about concavity, higher derivatives, and the second derivative test. All of these are just an extension of what we've been doing. We've been talking about first derivative test, increasing, decreasing, relative max, relative min. All of that's been dealing with our first derivative. Now we're going to move on to stuff we can do with our second derivative, but it's just an extension of what we've been doing. So for higher order derivatives, we're going to start with that because that'll kind of get us in the right mindset to go forward. Basically, what we're going to do is, in order to get to the second derivative, third derivative, fourth derivative, whatever we need to be able to get to this using our first derivative. So we're going to take our first derivative. Then to get to any subsequential derivatives from there, you just take the derivative of the previous derivative. So for example, it says find the second derivative of the following functions. So first thing we need is y prime is 4x. Well, since we need the second derivative, that's going to be y double prime, which just means we're going to take the derivative of our first derivative, which gives us 4. So in this nice easy case, the second derivative is just 4. For this one, it says find the second derivative, and then what is f double prime 1? We're going to leave that piece to the end. So f prime of x is 24x cubed minus 6x squared plus 3x to the negative 1/2. F double prime of x is, 24 times 3 is 72x squared minus 12x minus 3 over 2x to the negative 3/2. Well then, so we've done everything. Now we're going to come up here and worry about this f double prime of 1. So f double prime of 1 is 72 times 1 squared minus 12 times 1 minus 3 over 2 times 1 to the negative 3/2. So we get 72 minus 12 minus 3/2, or what is that? 60 minus 3 over 2. So 120 minus 3 is 117 over 2 would be our answer here. So we can do the same types of things depending on what we're given. So anytime you're given a square root and you know you're going to have to make higher derivatives, go ahead and write it raised to the 1/2. So f prime of x is 1/2 times 6x plus 5 to the negative 1/2 times 6. Like I told y'all before, simplify as we go. So 3 times 6x plus 5 to the negative 1/2. Now our second derivative is negative 3 over 2 times 6x plus 5 to the negative 3/2 times 6, which is negative 9 times 6x plus 5 to the negative 3/2. You could leave it like that, or if you wanted to, you could make this negative 9 divided by 6x plus 5 to the 3/2. No real difference in what we do there. Finding our second derivative here. So our first derivative, f prime of x, is low d high minus high d low over the bottom squared. It does come into play to go ahead and simplify this to make this 6 minus 6 ln x over 4x squared, which is, everything's divisible by 2, so 3 minus 3 ln x over 2x squared. That is only our first derivative. So now we need to take its derivative. F double prime of x is low d high minus high d low over our bottom squared. So we get minus 6x minus 12x plus 12x ln x by multiplying out over our 2x squared squared. This will give us minus 18x plus 12x ln x over 4x to the fourth. Everything is again divisible by 2. So minus 9x plus 6x ln x over 2x to the fourth. We could actually divide out an x inside there as well. So rather than rewriting this, I'm just going to make this 6 ln x and make that 2x cubed in the denominator. So now that we know how to take a higher order derivative, next we can talk about what we call as our concavity. A function is concave up if it is shaped like a coffee cup, and a function is concave down if it is shaped like an upside down coffee cup. So that kind of gives us kind of a little estimate of what we're kind of looking at, that for concave up, it looks like that, and for concave down, it looks like that. So that's kind of what we're talking about here. Now, a point of inflection. A point of inflection is very similar to what we've already been talking about in terms of critical numbers. Just a point of inflection is the critical number for our second derivative instead of the first derivative. So it's where our function changes from concave up to concave down, or from concave down to concave up. Now, to find the points of inflection, take the second derivative, set it equal to 0, solve. It's also where it does not exist. Now, to actually find our concavity, we need to actually look at our different values here to see what's going on. So let f be a function where f prime of x and f double prime of x exist. So our first and second derivatives must exist inside of our interval a, b. If f double prime of x is greater than 0 for all x in a, b, then the function f is concave up. If f double prime of x is less than 0 for all x in a, b, then the function is concave down. So it's very similar to what we did with critical numbers, except for we're doing it in the second derivative now. So we're told, find the point of inflection and where the function is concave up. So to do any of that, we need our second derivative. F prime of x is 12x squared minus 24x. F double prime of x is 24x minus 24. So that is our second derivative. We're going to set that equal to 0. So 24x equals 24. X equals 1. X equals 1 is our only point of inflection that we can have. So let's come over here. We're going to put 1 on our number line. We're going to test 0 and 2 into the second derivative there. Wherever you get it from normally is where we're going to put it back into. So f double prime of 0 is 24 times 0 minus 24 is negative 24. So it's negative. F double prime of 2 is 24 times 2 minus 24, which is positive 24. So it's positive. So our function is concave up on the interval from 1 to infinity. Our point of inflection, which I'm just going to denote POI, is the point 1, comma, we plug in f of 1, 4 times 1 cubed minus 12 times 1 squared plus 150. 4 minus 12 plus 150, so negative 8, so 142 is our point of inflection. So very similar process to what we've been doing, just now we're doing it with our second derivative. So for f of x equals 2x minus 8 e to the minus 2x. f of x, or f prime of x, is 2 plus 16e to the 2x. F double prime of x is negative 32e to the minus 2x. We set this equal to 0. There's no places where it is, so there are no points of inflection for this one. Since there's no points of inflection, no matter what we plug in, this is always going to be concave down based off of this. Because of this graph and everything. Something like, so it's concave down and it's not concave up. So, using this same one, this one over here of x over x plus 3, I'm going to jump over here, f of x equals x over x plus 3. So that means f prime of x is low d high minus high d low over the bottom squared. So we get x plus 3 minus x over x plus 3 all squared, which is 3 over x plus 3 all squared. This is f prime of x. So if we change this to 3 times x plus 3 to the negative 2 is equal to f prime of x, that means f double prime of x is minus 6 times x plus 3 to the minus third, or negative 6 over x plus 3 cubed. So setting this equal to 0, we get, the only place we get is from our denominator, which is x equals negative 3. Negative 3 is not in our domain, therefore it does not exist there. So we could figure out concavity. So negative 3, you could plug in 0, you could plug in negative 4. So negative 6 over plus 3 all cubed, and then negative 6 over 0 plus 3 all cubed. So this one gives us negative 6 over negative 1, which is 6, so it's positive. Here we get negative 6 over 27, so it is negative. So therefore it's concave up from negative infinity. So concave up from negative infinity to negative 3. There are no points of inflection because we can't plug back into the original. The other function we have is f of x equals 7 over x. We could write this as 7x to the negative 1, so that means f prime of x is negative 7x to the negative 2. F double prime of x is 14x to the negative third, which is 14 over x cubed. Set that equal to 0. Again, there is no points of inflection, but we do have places we could test around 0. So plug in negative 1, plug in 1. So 14 over negative 1 cubed is negative 14. We get a negative. 14 over 1 cubed is 14. We get a positive. So therefore it's concave up. From 0 to infinity, but there are no points of inflection. Now, we can have applications. It says, remember, if our first derivative is velocity, our second derivative is acceleration, your third derivative is actually called a jerk. and everything. So acceleration is the second derivative, so let's find the acceleration at time t. So s prime is 3t squared minus 18t squared. S double prime is equal to 6t minus 30 is equal to 16 minus 36t, which we can combine those to say minus 30t is our s double prime at t, or also known as acceleration. The next thing we can talk about is our second derivative test. Our second derivative test, you only want to use this when the problem asks you for it. If you try and use it at other points, it can be really cumbersome. It can lead you down to results where you still have to use the first derivative test. So only use this when the problem asks you to use it. So we want to let f double prime exist on some interval containing c and let f prime of c equals 0. If f double prime of c is greater than 0, then f of c is a relative min. If f double prime of c is less than 0, then f of c is a max. If f double prime of c is equal to 0, then no information is given. Remember, c is our critical value. So we are looking to see, we're going to take our first derivative, set it equal to 0 and solve, get our critical numbers, then we're going to plug our critical numbers into the second derivative. And then we're looking to see which one of these three conditions we have. If you have that last condition where it equals 0, so in other words, your critical number happens to possibly be a point of inflection, that means that you're actually going to have to go back and use the first derivative test. That's why it's not very good if we're trying to use this at all. So we're trying to find the time at which the drug concentration is a max. So you know what? We're going to play. We're going to use the second derivative test here. So k prime of x is 3x squared plus 27 times 4. So low d high minus high d low over the bottom squared. We want to simplify this. So we're going to get 12x squared plus 108 minus 24x squared over 3x squared plus 27 all squared. So minus 12x squared plus 108 is equal to 3x squared plus 27 all squared. If we set this equal to 0 and solve, denominator we don't care about. So minus 12x squared equals negative 108. X squared equals 9. X is equal to plus or minus 3. But keep in mind, we're talking to that X is a time. So we don't have negative 3 hours. So this is really going to give us X equals 3. So what we're going to do now, we got to take the second derivative of this bad boy right here. So if k prime of x is equal to negative 12x squared plus 108 over 3x squared plus 27 all squared, we need the second derivative of k. So low 3x squared plus 27 all squared times negative 24x minus negative 12x squared plus 108 times 2 times 3x squared plus 27 times 6x, all divided by 3x squared plus 27 all squared squared. See how this can get ugly really quickly. So notice that I have a 3x squared plus 27. I'm going to cancel it here. I'm going to cancel one of them here. This number is a 4, so I'm going to cancel and make it a 3. So we're left with 3x squared plus 27 times negative 24x minus negative 12x squared plus 108 times 12x all over 3x squared plus 27 to the third. There's no need for us to simplify this. We've already performed it. So this is our k double prime of x. Well, now let's plug in those two values that we got. K double prime of 3 and then k double prime of negative 3. This is in case, hey, you didn't realize that it was in negative. I'm going to show you what's going to happen here. So 3 times 3 squared plus 27 times negative 24 times 3 minus negative 12 times 3 squared plus 108 times 12 times 3 all over 3x squared, oh, not x squared, sorry. 3 times 3 squared plus 27 all to the third. If we plug in negative 3 times negative 3 squared plus 27 times negative 24 times negative 3 minus negative 12 times negative 3 squared plus 108 times 12 times negative 3 all over 3 times negative 3 squared plus 27 all raised to the third. So first, let's simplify this one up here. So when we plugged it in, assuming I didn't make any calculator issues, negative 0.025. If we plug this in using the other one, we would have gotten we would have got 0.025. So if we think about our rules, by taking the critical number and plugging it into our second derivative, if it's less than 0, we have a max. If it's greater than 0, we have a min. So we just showed that 3 gave us a maximum. So back up here, it says find the time at which the drug concentration is a max. X equals 3. This is ugly. We could have done this by our first derivative and not had to worry about that ugliness. So only use the second derivative when it tells you to. Now, This one says find the point xy of diminishing returns. So what we have to do here is we need to find our second derivative. So r prime of x is minus 3x squared plus 84x plus 800. R double prime of x is minus 6x plus 84 equals 0. Minus 6x equals minus 84. X equals 14. We also have to make sure that we are inside this bound. We only found one value here, so we could actually be pretty accurate to know that x equals 14 is our answer. To continue on with that, you would actually just draw your number line here, put 14 on it. You could plug in 0, you could plug in 15. So plugging in 0 into here, we get a positive and then a negative. So therefore, we know it is our maximum there. So then you would have 14, comma, you plug 14 into the original, you find R of 14. So that's 10,000 minus 14 to the third plus 42 times 14 squared plus 800 times 14. And when we plug that in, we get 26,688. So this would be our point of diminishing returns. So depending on what we're given, depends on the complexity of these. Notice how some of them are more complex than others. So we just gotta have, it's going to take time. So we're told find all points of inflection in the concavity. So f prime of x is minus 4x e to the minus x squared. So our second derivative has a product rule, minus 4e to the minus x squared plus negative 4x times minus 2x e to the minus x squared, which is minus 4e to the minus x squared plus 8x squared e to the minus x squared. You can pull out a minus 4e to the minus x squared. So you get 1 minus 2x squared. We set this equal to 0 and solve. So 1 minus 2x squared equals 0. 1 equals 2x squared. 1/2 equals x squared. X equals plus or minus the square root of 2 over 2. So negative root 2 over 2, positive root 2 over 2 are two values. So we could use 0, 3, and negative 3 to plug into our second derivative here. When you plug in 0, you get minus 4e to the 0, 1 minus 0. So you get negative 4. So now when we plug in 3 and negative 3, you would get minus 4e to the negative 9th, 1 minus 2 times 9. For both of these, it does not matter. So you get negative 4e to the negative 9th times 1 minus 18 is negative 17. So you get 68e to the minus 9th, which is greater than 0, so plus and plus. So we were looking for all the points of inflection and the concavity. So when it says concavity, we're wanting to know where is it concave up Where is it concave down? So it is concave down between negative square root of 2 over 2 and positive square root of 2 over 2. And then it's concave up, negative infinity to negative root 2 over 2. And then root 2 over 2 to infinity. Our points of inflection, we actually have 2 of them. It's going to be root 2 over 2 comma something and negative root 2 over 2 comma something. We got to plug these back into our function of 2e to the minus x squared. So 2e to the minus x squared, or 2e to the minus of root 2 over 2 all squared, and then 2e to the minus negative root 2 over 2 squared. They're both going to give us the same answer. So when we do that, we should get approximately 3.297 in each one of our cases here. So it didn't look like that hard of a problem, but it turned out to be a little ugly of a problem right here. So we need to be aware of that whenever we